Hello, everybody. We're going to go ahead and get started. My name is Gabriel Cardona, and I am developer evangelist at Avalanche. And you'll have to forgive my absence. I was scheduled to give this presentation in Austin earlier this week, but I had to have a root canal, and it prevented me from actually flying to Austin. So the moral of the story is to take care of your teeth, my friends. They do a lot for you, so do a lot for them. Okay, so today's presentation is going to be a high-level introduction to the Avalanche network. Let me go ahead and share my screen here. We're going to talk about who we are at Ava Labs, what we've been building over the last couple of years. We're going to dig into a few of the unique attributes of the Avalanche network, which are Avalanche Consensus, Subnets, and virtual machines. So first, who is Ava Labs? We're a world-class team of experts in the fields of computer science, economics, law, and finance. And our offices are located in NYC and Miami, but we have team members spread all over the world. And I personally am located with a handful of other teammates in the San Francisco Bay Area, where I'm coming to you from today. And I believe that we have team members on every single continent other than Antarctica. So we are truly a worldwide team. We're passionate individuals with a vision to create a frictionless world by redefining the way people build and use finance applications. And the Ava Labs team has collective experience from leading Fortune 500 finance and tech companies through to high growth blockchain companies. Here are some of the companies that my amazing teammates were at prior to joining Ava Labs. I myself was at Bitcoin.com. You can see on the bottom row there, where I was the Global Director of Developer Services prior to joining Ava Labs. And I've been working in the blockchain space for quite a few years now, and I genuinely believe that Ava Labs and the Avalanche network are very important milestones in this entire blockchain journey. Here is our C-level suite. At the top left is our co-founder and CEO, Amin Gun Sarir, who was a professor at Cornell for over 20 years. And one of his many claims to fame is that he was the creator of one of the very first virtual currencies for peer-to-peer systems, which used proof of work, and it was called Karma, way back in 2003. So 5 years before Satoshi released Bitcoin, Gun and his team were already solving problems in this space. Below Gun, to the bottom left, is our president, John Wu. John attended both Harvard and Cornell and was previously co-founder of Sego and Shoreview Capital. On the top right is another one of our co-founders and COO, Kevin Seknicki. Kevin is a PhD from Cornell and was previously at Microsoft and NASA. And lastly, on the bottom right is our other co-founder and our Chief Protocol Officer, Ted Yin. Ted is also a PhD from Cornell and one of the creators of Hot Stuff, which is the classical consensus protocol behind Facebook's Libra or DM network. And of course, now he's at Ava Labs working on Avalanche Consensus. Who am I? As I mentioned, my name is Gabriel Cardona. I'm developer evangelist at Ava Labs, and I lead our developer relations squad. The developer relations squad has three main functions. First, we maintain Avalanche.js, which is our TypeScript and JavaScript library for interfacing with the Avalanche network. Next, we do partner integrations. We spend a lot of our time on Slack, Telegram, and Discord and email, helping new teams and companies understand our technology stack and understand how to integrate it with their existing technology stacks. Lastly, I go around to a lot of conferences, conventions, hackathons, and meetups, and I give presentations like today, hoping to inspire people to build amazing applications on the Avalanche network. So why do I do what I do? I genuinely believe that there is no more valuable resource on the entire planet at this moment in time than a competent, hardworking, and creative engineer. And I feel that way because we are at a unique time in the evolution of our species where we need to solve problems at scale and at velocity. And fortunately for us, there have been so many radical breakthroughs in computer science over the last 200 years or so, going all the way back to Ada Lovelace and Charles Babbage with his difference and analytical engines until now. There have been so many breakthroughs that we have a tool set which is unlike any time in all of human history. So now we just need hardworking, competent, and creative people to step forward and build the systems which solve the problems. So I often say, there's never been a better time in all of human history to have a great idea, find a group of like-minded people, raise capital, and change the world and uplift the human condition in a really big way. So hopefully I can inspire someone listening today to build their game-changing idea, and ideally to build it on the Avalanche network. And of course, we are hiring. If you're in the field of computer science, economics, law, and or finance, and anything I talk about today excites you, please feel free to reach out to me. My contacts will be on the last slide, or check out avalabs.org/careers. We're hiring across the board: business development, engineering, marketing, operations, product, and probably more than that. So please check it out. Okay, we've got that out of the way. Now let's dig in and talk about what we came to talk about today. What is Avalanche? Avalanche is a global financial network for the issuing and trading of all digital goods. We enable potentially millions of validators to process thousands of transactions per second with near instant finality using a protocol which is completely green and quiescent. And we've paired this high throughput and fast finality protocol with an architecture that can meet the needs of unique financial services and decentralized applications. We accomplish this through this notion of subnets. So subnets allow anyone, anywhere, to spin up a tailor-made network with custom virtual machines and complex validator rule sets. So the way to think about Avalanche is a network of networks. It is a platform of platforms, and we envision thousands and thousands of public and private subnets all emerging into this global marketplace, which we call the Internet of Finance. So before we start, I want to give a brief history on the evolution of the blockchain revolution. And I suspect that most of this information on these next few slides won't be news to many of the people watching this today. But in my life, I have discovered that to really and truly appreciate where you're headed, it helps if you really understand where you're coming from. And it'll help to get us all on the same page. So first, Blockchain 1.0. Blockchain 1.0 was Bitcoin. And in the beginning was Bitcoin, and the Bitcoin was good. And Bitcoin proves to the world the need for a robust and a decentralized payment network. It started its life out as peer-to-peer electronic cash, but for better or worse, that's not what it ultimately grew into, which is much more akin to digital gold. And I admit that I was salty about that for a long time. I really, really love the vision of peer-to-peer electronic cash, but I've matured a lot over the last decade, and my viewpoint on that has changed a lot. Now I realize that Bitcoin has grown into a hedge against inflation for the mom and pop investor. Well, what is inflation? In economics, inflation is a general increase in the prices of goods and services in an economy. And what are the long-term impacts and effects of inflation? When the general price level rises, each unit of currency buys fewer goods and services. Consequently, inflation corresponds to a reduction in the purchasing power of money. And as I see it, inflation is a silent form of theft. And some people argue that taxation is theft. However, with taxation, at least you can point to some common utilities and infrastructure, which we all depend on, such as roads or the police or the military. And we can say, well, that's what our taxes are used for. But with inflation, your purchasing power is simply going down continuously with nothing that you can point to in return. And 1 out of every 5 US dollars that have ever been printed in the entire history of the United States were printed in 2020. The purchasing power of every single person listening to today's US dollars has decreased by about a corresponding amount in the last couple of years. And that trend is going to accelerate. And I certainly feel it here in the San Francisco Bay Area, where everything from rent, bills, groceries, gas, etc., have all increased in price or decreased in quantity. And this is potentially what the beginning of hyperinflation looks like. And if you don't think that hyperinflation can happen in the US, I urge you to check out Zimbabwe, Greece, Venezuela, Argentina, etc. Inflation and hyperinflation absolutely can happen to fiat currencies. So Bitcoin and other cryptos, such as AVAX, which is the token for the Avalanche network, allow you to opt out of inflation. So trust me, your kids will thank you. And as big of a leap forward as Bitcoin was, it still has its downsides, of course. Namely, it is slow. Bitcoin only does a handful of transactions per second on the base layer. Of course, I'm aware of the Lightning Network, but on the base Bitcoin layer, it only does a handful of transactions per second. It does not have fast finality. It takes an hour before you can be confident that your transaction won't be reorged. It's not lightweight and green. Many people know the meme about Bitcoin burning more energy each day than some nation states. But I don't think that that is a huge deal, actually. Every single hour, enough energy falls on the planet in the form of sunlight to meet over 100% of our energy needs, including fossil fuel, renewable, and nuclear energy. So really the problem is about harvesting this energy, storing it, and then transporting it. And these are all problems which I believe will be solved in our lifetime. So in the long term, I don't think that Bitcoin burning so much energy is a huge problem, but it's certainly a problem in the short term before we have those problems solved. And it's really bad optics. So you often see headlines that say, crypto is even worse for the environment than you thought. Certainly referring to what I'm talking about here, which is that Bitcoin's proof of work burns more energy each day than some nation states. Bitcoin has a scripting language, which is creatively named Script, but it's archaic and cumbersome to use. It is stack-based, and it doesn't feel modern for someone who has come of age in the era of Golang or TypeScript or Python, etc. And lastly, Bitcoin does not have tokens. So technically, there is an opcode called opreturn, which enables you to write 80 bytes of arbitrary data to the blockchain, which can be used to encode asset creation, minting, transferring, and burning commands. You can then write wallets, which can tease out those 80 bytes and decode them, from which you can have token systems. It's really just a technical hack, and the tokens aren't native to the Bitcoin virtual machine. So in summary, Bitcoin was a huge leap forward and kicked off a financial revolution, but it left a few things to be desired and inspired engineers to try and do better. And I just want to say that Bitcoin had a radical impact on the lives of many people, myself certainly included. In 2011, I fell down the Bitcoin and the crypto rabbit hole, and I suspect I will never emerge. And it has taught me so much about technology, money and finances, social dynamics, and really so much more. So as gratitude to Satoshi, my wish is that he or she or they or it, whatever Satoshi was, I hope that they're out there living their best life. I really hope that Satoshi is happy and healthy and working on the next generation of amazing technology. Ethereum is blockchain 2.0. Ethereum is a decentralized app which enables developers to launch their own apps on top of it in the form of smart contracts. Prior to Ethereum, if you wanted to launch your own decentralized application, then you had to roll your own network. And this led to a very bespoke environment where few projects were able to reach the network effects required to tip and go mainstream. By enabling developers to launch their dApps on top of Ethereum, it enabled a huge network effect. This led to a wave of innovation around tokenomics, initial coin offerings, non-fungible tokens or NFTs, decentralized finance, prediction markets, yield farming, distributed autonomous organizations, and so much more. And I remain a huge fan of Vitalik and his team. And I think that Vitalik is one of the great thinkers of our generation. And he's still a young man. And I suspect that his best days are still ahead of him. So similar to Linus Torvalds, chapter 1 being Linux and chapter 2 being Git, I'm still waiting to see what Vitalik does for his chapter 2. We view Avalanche as blockchain 3.0 technology. And similar to Bitcoin and Ethereum, we're introducing a handful of new paradigms, which we're going to go over today. We're going to discuss how Avalanche Consensus is the third major paradigm over 40 years in the field of consensus. We'll discuss how Avalanche is unlike most other existing blockchains in that it is a network of networks instead of a single virtual machine and a single set of validators. And we'll also dig into virtual machines, what they are, and how they fit into the greater picture of the Avalanche network. And lastly, we will discuss how Avalanche enables developers to spin up their own tailor-made network with custom virtual machines and complex validator rule sets. So first off, what is consensus? Seems like an appropriate question for this particular event. And if you work in the blockchain space, you probably hear the word consensus a dozen times each day. But what exactly is consensus? Consensus is the process by which a group of independent validators come into agreement on a decision. So it's really that simple. How do you get a bunch of people or machines to agree on a decision? It's a very rich field of computer science that goes back at least 40 years. As I mentioned, Avalanche Consensus is the third major paradigm in the field of consensus. The first was called Classical Consensus, and it goes back to the 70s and the 80s. Classical Consensus has low latency and very high throughput. It's very lightweight, it's very green. However, it isn't very scalable nor robust, and it performs poorly in adversarial conditions. In 2008, 2009, when Satoshi Nakamoto released Bitcoin, the world was introduced to the second major paradigm in the field of consensus, what ultimately became known as Nakamoto Consensus. Nakamoto Consensus is very scalable and robust, and it's decentralized, but it doesn't have low latency. As I mentioned, it takes around an hour to be sure your transaction is sufficiently settled that you won't experience a reorg. It doesn't have high throughput. Bitcoin only does a handful of transactions per second. Again, of course, I am aware of second layer solutions like the Lightning Network. For this talk, I'm referring specifically to the layer 1 Bitcoin protocol, the Bitcoin network. Bitcoin is not lightweight or green. As I mentioned, or Nakamoto Consensus is not lightweight or green. As I mentioned, Bitcoin burns more energy each day than some nation states. And lastly, Nakamoto Consensus performs okay in adversarial conditions up to the famous 51% attack. In 2018, a pseudonymous group going by the name Team Rocket released a white paper on the Interplanetary File System, or the IPFS, describing a third major paradigm shift in the field of consensus. This new breakthrough was known as Avalanche Consensus, and Avalanche Consensus is the perfect storm of features from classical and Nakamoto Consensus. It's very scalable, very robust, and very decentralized. As of this moment in time, there are currently around 1,500 full block and vertex producing validators on the Avalanche network. The protocol theoretically enables millions of validators, so it's very, very decentralized. Avalanche Consensus has low latency with sub-second immutable and irreversible finality. There is no notion of a reorg on Avalanche. Within a literal blink of a human eye, your transaction has settled completely for all time. Avalanche has very high throughput with 4,500 transactions per second. It's very lightweight and green. It can be run on a PC. It can be run on a MacBook. It can be run on a VPS droplet out on the cloud. And in the future, it will be able to be run on Internet of Things devices. And Avalanche Consensus is parameterizable, so it performs very well in adversarial conditions. Technically, Avalanche is a metastable consensus protocol inspired by epidemic protocols and government networks. The process used to determine whether a transaction is preferred or not is referred to as repeated random subsampling. Here is a great demo created by our chief professor, Ted Yin. As I mentioned, Ted was one of the creators of Hot Stuff, which is the classical consensus protocol behind Facebook's Libra or DM network. And he is now at Ava Labs working on Avalanche Consensus. In this demo, the squares represent different nodes, and the color of each square represents its current proposal. So is this transaction blue or is this transaction orange? And briefly, it's worth noting that Avalanche Consensus can handle non-binary decisions. So for example, if you give it 5 options instead of 2, it will still reach immutable and irreversible consensus. For the sake of this demo, and in most transaction-related decisions on a blockchain, we're going to go with a binary decision. Is this blue or is this orange? The darkness of the color shows the node's conviction in that proposal. Does this node kind of think the decision is blue, or does it really believe the decision is blue? When I click start, each node will begin repeatedly and randomly sampling its peers and changing its own color and conviction based on the responses. Expectedly, all nodes will collapse to the same color in the end. So you can see it only takes a couple rounds of sampling and the entire set will tip and avalanche into consensus. Now I want to play that again because I think it's really beautiful. Again, you can see that it only takes a couple rounds of sampling and the entire set will actually tip and avalanche into consensus. Hopefully that gives you a bit of an intuition about how Avalanche Consensus works. So that's Avalanche Consensus, the third major paradigm shift in the field of consensus. Now, let's discuss how Avalanche is a network of networks. As I mentioned, Avalanche is different than traditional crypto networks like Bitcoin and Ethereum that have one virtual machine and one set of miners or validators. It is a network of networks with compound network effects. And to help visualize this, I have a really great slide. Credit and shout out to the amazing CryptoSec. You can see the Twitter handle at the bottom right. Please go follow them on Twitter and check out their Medium account for some incredibly deep and insightful posts on the blockchain. Thank you and hat tip to CryptoSec. So here you can see the gray oval represents the Avalanche network. Within the network are many different subnetworks or subnets, which are represented by the different circles. In each of those subnets are green squares which represent the different virtual machines or blockchains which are running on those subnets. The lines between the subnets show that you can move assets between the different subnets. And at the top, you can see Bitcoin, Ethereum, and Cosmos, with lines representing the ability to bridge assets from those other networks back and forth between the Avalanche network. Currently, bridge.avox.network supports bridging assets to and from Ethereum. And recently we announced that Bitcoin support is coming to the bridge soon. Since launch less than 1 year ago, the bridge has been used for around 300,000 transactions with nearly 50 billion US dollars in ERC20 assets moving between Ethereum and Avalanche. And those are pretty stunning numbers. $50 billion is a big number. And we expect with the addition of Bitcoin, that number is going to rise much, much higher. So props to the bridge team. Those guys and gals are absolute wizards. And I often say that Avalanche's subnet architecture is primed for compound network effects. What do I mean by that? Well, most everyone has heard of network effects. Technically, network effects are known as Metcalfe's law. Metcalfe's law that says that a network's value is proportional to the square of the number of nodes in the network. For example, if a network has 10 nodes, its inherent value is 100. 10 times 10 equals 100. In other words, a product or service gains additional value as more people use it. A great example of network effects is the telephone network. If only one person has a telephone, it's not very useful. For every additional person who plugs into the telephone network, then the entire network grows in value for every other user. And perhaps the canonical example of network effects is money. If only one person accepts a currency, then it's not very useful. For each additional person that accepts the currency, then it becomes more valuable for every other user who can then use that currency for purchasing goods and services. So that is network effects. But what about compound network effects? Compound network effects are known as Reed's law. And Reed's law says that the utility of large networks, particularly social networks, can scale exponentially with the size of the network as the number of possible subgroups grows much more rapidly than either the number of participants or the number of possible pair connections. So even if the utility of groups available to be joined is very small on a per group basis, eventually the network effect of potential group membership can dominate the overall economics of the system. And so Avalanche's subnets are designed and primed for compound network effects. Next, we have virtual machines. A virtual machine defines the application level logic of a blockchain. In technical terms, a virtual machine is a state machine. It specifies a blockchain state, state transition function, transactions, and then an API through which users can interact with your blockchain. Every blockchain running on Avalanche is an instance of a virtual machine. The way to think and conceptualize about virtual machines is like a class in object-oriented programming. A class is a description of an object. It's a template from which you can instantiate as many objects as you wish. And each of these objects, though derived from a common template, are all completely unique and logically separate entities with their own state. So similar to a class, a virtual machine is a blueprint or a template from which you can instantiate as many instances of a blockchain as you wish. And each of these blockchains, though derived from a common template, are unique and completely logically separate entities with their own state. And as a developer, when you write your virtual machine, you don't need to concern yourself with lower level logic like networking. You don't need to worry about consensus. You don't need to worry about the structure of your blockchain. Avalanche does all of this for you behind the scenes so that you can focus special sauce, which makes your virtual machine unique. Why virtual machines? At first, blockchain networks had one virtual machine with a predefined static set of functionality. This rigid, monolithic design limited what blockchain-based applications you could run on these types of networks. People who wanted custom decentralized applications had to roll their own entirely new blockchain network from scratch. This requires a great deal of time and effort, offers limited security, and in general resulted in a very bespoke, fragile blockchain that never got off the ground and achieved the network effects required to tip and go mainstream. As mentioned before, Ethereum made a huge step forward solving this problem with smart contracts so that developers didn't need to worry about networking and consensus. But creating decentralized applications was still hard. The Ethereum virtual machine has low performance and imposes restrictions on smart contract developers. Solidity and the other few languages for writing Ethereum smart contracts are unfamiliar to most programmers. They're not very expressive and they don't fit into the rest of your development workflow. Avalanche's virtual machines make it easy to define a blockchain-based decentralized application. And rather than new limited languages like Solidity, developers can write virtual machines in Golang, and using a gRPC API, you can actually write your virtual machine in a language other than Golang, as long as your virtual machine implements a certain interface. So the way it works is your blockchain can run as a separate process from Avalanche Go and can communicate with Avalanche Go over gRPC. And this is enabled by RPC Chain VM, a special virtual machine that uses Go plugin and wraps another virtual machine implementation. The C chain, for example, runs the core ETH virtual machine in this fashion. RPC Chain VM has two important parts: a server and a client. The server runs its own process and allows the underlying virtual machine's methods to be called via gRPC. The client runs as part of Avalanche Go and makes gRPC calls to the corresponding server in order to update or query the state of the blockchain. And lastly, we have subnets or subnetworks. A subnet is a dynamic set of validators working together to achieve consensus on the state of a set of blockchains. Again, a subnet is a dynamic set of validators working together to achieve consensus on the state of a set of blockchains. And each blockchain is validated by exactly one subnet, and one subnet can validate many blockchains. A node can be a member of many subnets. So, to visualize the heterogeneous or rich and diverse nature of the Avalanche network, picture this. A virtual machine is the application level logic of your blockchain. It's the template and can be instantiated into many different blockchains, some of which are public and some of which are private. A blockchain is an instance of a virtual machine. Each blockchain is validated by exactly one subnet. A subnet can be on a spectrum of completely public to all the way locked down and totally private, and can validate many blockchains, including many instances of the same virtual machine. A node can be a member of many subnets, validating many blockchains, including many instances of the same virtual machine, some public and some private. So Avalanche is truly a heterogeneous or rich and diverse in nature network. Subnets manage their own membership, and they can require that their constituent validators have certain properties, which is very useful. So, compliance. Avalanche's subnet architecture makes regulatory compliance manageable. A subnet may require validators to meet a set of requirements. So, for example, you can say that all validators in my subnet must be located in a given country or a certain legal jurisdiction. You can say all the validators in my subnet have to pass certain KYC AML requirements. You can say every validator in my subnet has to hold a certain type of license. There's also support for private blockchains. You can create a subnet where only certain predefined validators may join, and create a private subnet where the contents of the blockchains would be visible only to those validators. It's ideal for organizations interested in keeping their information private. There is also separation of concerns. In a heterogeneous network of blockchains, some validators will not want to validate certain blockchains. simply because they have no interest in those blockchains. The subnet model allows validators to concern themselves with blockchains that they care about. This reduces the burden on validators. There's also application-specific requirements. Different blockchain-based applications may require validators to have certain properties. Suppose there is an application that requires large amounts of RAM or CPU power. A subnet can require that validators meet certain hardware requirements so that the application doesn't suffer from low performance due to slow validators. So next, let's talk about the primary subnet. This is a visualization of our primary subnet. Our mainnet went live in August 2020. And when we went live, we had one subnet initially called the primary subnet. And on the primary subnet, there are 3 blockchains. There is the X chain, which is an instance of the Avalanche virtual machine. There's the P chain, which is an instance of the platform virtual machine. And there is the C chain, which is an instance of the Ethereum virtual machine. Let's talk about each one of those briefly. The X chain, as I mentioned, is an instance of the Avalanche virtual machine, and it is called X for exchanging assets. This is where you can issue variable and fixed cap assets, SecP assets, as well as non-fungible tokens. And this is where AVAX was issued. AVAX is a fixed cap asset. There will only ever be 720 million of them, and they were issued on the X chain. The X chain is a DAG. It's a directed acyclic graph data structure, and it has partial ordering. So it's very good for commutative transfers, such as asset transfers and simple tokens. And it's parallelizable, it's prunable, it has extremely high throughput, 4,500 transactions per second, and nearly instant, sub-second, immutable, and irreversible finality. Assets which are issued on the X chain are known as Avalanche native tokens, or ANTs. Next, we have the P chain. The P chain is an instance of the platform virtual machine. It is actually a linear chain. It uses UTXO. I should mention the X chain uses UTXOs. The P chain is a linear chain, so it has total ordering, but it uses UTXOs. The P chain is basically our administration chain. You can use it to launch new subnets. You can use it to validate. You can use it to delegate. You can use it to launch instances of blockchains on subnets. And lastly, there is the C chain. The C chain is an instance of the Ethereum virtual machine. It's called C for contract, smart contract. It is a linear chain. It has total ordering, and it's really good for smart contracts, of course, because it's an Ethereum virtual machine instance. So it has 100% backwards compatibility with existing Ethereum developer tooling. So if you use Truffle or Remix or MetaMask or Hardhat or all of the different Open Zeppelin, all of the different tooling which exist in Ethereum and other EVM ecosystems, we have 100% backwards compatibility with that tooling. So if you have a dApp which is live today on Ethereum and you've been suffering from high network fees or slow throughput, all you need to do is add our C chain as a new network ID, and you can just deploy your smart contract to our C chain with no problems at all. As I mentioned, it's 100% backwards compatibility, so it executes EVM contracts and can do DeFi and distributed autonomous organizations, prediction markets, all of the things which I mentioned. Of course, it also has compatibility with ERC 721, ERC 20, ERC 1155. Again, 100% backwards compatibility with existing Ethereum developer tooling. So in summary, Avalanche is a global financial network for the issuing and trading of all digital goods. We enable potentially millions of validators to process thousands of transactions per second, near instant finality, using a protocol which is completely green and quiescent. And we have paired this high throughput and fast finality protocol with an architecture that meets the needs of unique financial services and decentralized applications. We've accomplished this with this notion of subnets. Subnets allow anyone, anywhere to spin up a tailor-made network with custom virtual machines and complex validator rule sets. Avalanche is a network of networks. It is a platform of platforms where we envision thousands and thousands of public and private subnets to all emerge into this global marketplace, which we call the Internet of Finance. So thank you very much. I want to express gratitude to everyone listening today and anybody listening in the future. Thank you so much. I would like to express gratitude to the Consensus team. Thank you very much for the opportunity to present and let everybody know about the amazing Avalanche network. And I would like to express gratitude to the Ava Labs team. It is truly an honor and a pleasure to work with you all of you amazing block stars, to change the world each day. As I mentioned, my name is Gabriel Cardona. I'm developer evangelist at Ava Labs. You can find me on Twitter at CG Cardona. It's the same handle on Telegram. So if you have any questions or if you just want to connect, feel free to reach out to me. Have a blast and enjoy the rest of your time at Consensus. Thank you so much. Cheers.